So today we're going to learn about Cpctc, okay, which is really fun to say. Cpctc, as you can read, is with side, 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 angle, and angle, side. You know how to use 3 parts to show that they're congruent. So you did that with all your proofs. You did your red with a congruent side or angle, green with a congruent part, blue with a congruent part, and then you'd say your triangles are congruent. Well, what if they want you to prove that some other side is congruent? That's not like a reflexive property or a vertical angle. That's when you use the Cpctc. Okay? It stands for, and what I use for this one is my rainbow pen. But what I would use for you is maybe another colored pen to help you today with your notes. But by definition, what it stands for is corresponding parts of congruent triangles are congruent. Now that's super long to write in a proof. So what people write in their proof is that the CP, so C for corresponding, P for parts, C for congruent T for triangles, and C for congruent. So every single time after you prove your triangles congruent by side, angle, side, what you're going to prove is another congruent side or angle. And the reason is going to be Cpctc. Now there's another blank after this with 6 because you might have to do a little bit more. So our later proofs after, I'll show you what I mean by that. But every single proof has, you know, you're trying to get a congruent side or angle in red, then blue, or red, then green, then blue, then congruent triangles. Every single time the next one is Cpctc after this one. Every single time. Okay, so let's look at our first one. Okay, the first thing you need to write down is what you need to prove. Now this one's already written down and wrote all the statements for you to kind of get you warmed up. But they wrote EF is congruent to EG. So I guess you don't need to do that one part yet. So now, just like yesterday, I'm going to start with my red, and sure enough, I have a congruent part. So I have EDG is congruent to EDF. And my letters are so small, but that's where those 2 angles are. So I'm going to mark them up. So I have a congruent part. Red's done. Now I'm going to move on to green. DE is congruent to DE. Now that's not in my given, okay? But notice that they're talking about that shared side. This is the reflexive property of congruence. So there's a congruent part. Now I'm going to move on to blue. DEG and DEF are right angles. Those are given. So they're saying these 2 are right angles. Well, that's not congruent, so I'm still sticking with blue. So now they said those same angles are not only right, but they're also congruent. That's a reason we used the other day. This is all right angles congruent. Right, so blue's done. Now I can say my triangles are congruent. And sure enough, that's our next step. We say the triangles are congruent. Now looking at my picture, I have 2 angles and a side. So I need to look at where that side is, and the side's included. It's in between the 2 angles. So my reasoning for this is ASA, angle, side, angle. Now, what they're saying, and this is where that Cpctc comes from, we have EF congruent to EG. EF congruent to EG, they're saying another part. And notice it's right after saying my triangles are congruent. So my reason for this is corresponding parts of congruent triangles are congruent. Once I prove that these triangles are the same, I can say all their other parts are the same. I can say all their other sides and all their other angles are also the same. So in this step, after proving the triangle's congruent, They wanted EF and EG, but I could also use Cpctc for another angle or the remaining side. Hey, next one. Here's one that's more blank. So the first thing I'm going to do is write what I need to prove last. So the other day, this was always triangles being congruent. But on today, it's going to be a lot different. All right, so here we go. Start with red. Angle Q is congruent to angle R. So congruent part. Now that I have another congruent part, I can move on to green, which is another congruent part. So I have angle QPS congruent to angle RSP. So I have those two. Great. So next, I'm going to move on to blue, which is a shared side. So I'm going to say PS is congruent to PS by the reflexive property of congruence. Now, after I have my three congruent parts, now I can say triangles are congruent. So now, unlike the other day, you didn't have to worry about writing a triangle congruence statement because it was what you needed to prove. So you would just copy what was here. Now you have to write it yourself, and that's where you have to watch your ordering. Now, the way my strategy for this is I look at the markings. So if I start, say here with angle Q, notice how it has a red marking. I'm going to start with Q, go to P because it has a green marking, and then finally to S. So when I write my other one, I remember, okay, I went from red to green to nothing written there. And I'm going to do that here. So I'm going to go R, because that has red, R to S, which is green, and then P. So that congruent statement, remember, Q and R are corresponding, P and S are corresponding, S and P are corresponding angles. Okay. So the reason now is one of the side, angle, side, angle, side, angle, 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 side. I have two angles and a side. The side's not included, so this is angle, angle, side. Next step, they're trying to tell me that they want another congruent part. They want the SQ and the PR congruent. Well, if the triangles are congruent, sure, so are their parts. So this is Cpctc. Always follows your triangle congruence statement. Next one, write what you need to prove last. So angle P is congruent to angle Q. And I start with red. Not a congruent statement, so I'm going to have to use it. So they're saying KL is perpendicular to PQ. Well, that gives me right angles. I'm going to say angle 1 and angle 2 are right angles. And I know that because those lines are perpendicular, or those segments are perpendicular. So this is the definition of perpendicular lines. Well, that's not a congruent statement, so I stay with red. And I notice if angle 1 and 2 are right angles, then they must be congruent because all right angles are congruent. Now that I have a congruent part, then I move on to green. I have KL bisecting angle PKQ. PKQ, that's right here. Well, if that's true, then angle 3 must be congruent to angle 4. We have bisects. This is the definition of an angle bisector. That's a congruent part, so I move on to blue. So this is where I start looking at my go-tos. Okay, I have vertical angles in that reflexive. Well, looks like reflexive. I'm going to say KL is congruent to KL by the reflexive property of congruence. After I have blue, that's a congruent part, I can say my triangles are congruent. So same thing, I'm going to watch my order. I'm going to go PKL, triangle PKL, so notice no markings, green, red. So I'm going to go QKL, no markings, green, red, is congruent to triangle QKL. And the reasoning for congruent triangles so far is that side, 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 angle, side, angle, side, angle, 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 side. I have two angles and an included side, so this is angle, side, angle. Now, following that, we have, if the triangles are congruent, then their corresponding parts are. So my reasoning here is Cpctc, which is really fun to say really fast. Cpctc. So what you should write on the side of your paper next to this proof is Cpctc is fun to say. So write that on the side. Cpctc is fun to say, especially fast, but that's a bonus. All right, so next one. Write what you need to prove last. MD is congruent to NR. All right, here we go. Start with red. Parallel. All right, so I have RN parallel to MD. Now, there's a lot of triangles going on in here, okay? So the two transversals that are touching both, one has a lot of numbered, one does not. I'm going to use this one because I can say that angle 8 and angle 7 are congruent. Because if lines are parallel, then those angles are congruent because those are alternate interior angles. So parallel then alternate interior angles congruent. Congruent part, move on to green. MN bisects RD. So MN bisects RD. So the definition of a bisector is cutting into two congruent parts. So if it's a segment it's cutting, this is going to make segments congruent. So I'm going to say Rx is congruent to dx by the definition of a segment bisector. Now that green's done, I move on to blue. And I need to try to come up with another congruent part. And I notice that I have some vertical angles going on. I see that angle 5 is congruent to angle 6 by the vertical angle theorem. After I have angles congruent, then I can say my triangles are. So my two triangles with all the markings are these two. So to name them, I'm going to go NXR, triangle NXR, because I remembered N has red, X has blue, R has nothing. So here I'm going to start at N because that has red. So M, then blue, X, and then D. And from the markings, those two are congruent by angle, angle, side, because I have two angles and a non-included side. Next, we're going to prove that another part of those triangles are congruent. So what do you know? The reasoning here is Cpctc, which is fun to say. Right, here we go. Write what you need to prove first. This is where these can start getting a little trickier. So AG bisects NR. Interesting. All right, so here we go. Start with red. Parallel. All right, so I need to get some congruent parts here. This one actually has two answers. Because notice how you can draw two transversals that are touching both triangles. What I'll do is maybe this one, but you could use the other one. Okay? Now looking at that, I see that these two angles are congruent, angle N and angle R, so that's what I'm going to write. Angle N is congruent to angle R. I've paralleled then, and those are alternate interior angles, so they're congruent. So if I erase my markings here, besides the marking that they're congruent, then I move on to green. So NA is congruent to RG, so NA and RG, so congruent parts, sweet. Now I move on to blue. Well, I see the X. So I'm going to name those congruent. So angle NXA is congruent to angle RXG by vertical angle theorem. So now I can say my triangles are congruent. So I'm going to say triangle ANX is congruent to triangle. So I went nothing, red, blue. So I'm going to go nothing, red, blue. So GRX. And from the markings, I have two angles and a side. The side's not included. So this is going to be angle, angle, side. Now this is kind of different from the other ones because usually we ended with Cpctc. This one we're not. Now Cpctc almost always follows triangles being congruent. Okay, so it always follows this. But it's not always last. And that's a mistake people make. So what I'm going to have to do is I'm going to have to look at what I need to prove. So the definition of Cpctc is that corresponding parts of congruent triangles are congruent. So I've proven the triangle's congruent. But what I want to prove in this proof is that AG bisects NR. So I need to pick the right side or angle to say is congruent here. So this part 7 is true. So if AG, so here's AG, bisects NR, okay, if that's true, these two sides should be congruent. So this is what I'm going to do. I need to pick out of all the other remaining sides and angles, I'm going to say NX specifically is congruent to XR by Cpctc. I can say that because the triangles are congruent, so I can say the rest of the parts are. But I picked that specific segment because I need to prove that there's a bisector here. And the reason I know that's a bisector now is because the definition. So the definition of a segment bisector. So Cpctc is not always last. It always follows a triangle congruent statement. So there's a difference there. Now this last one might freak you out a little bit, but you can do it. So we're going to write what we need to prove last. So way down here, BD is perpendicular to AC. Now this one is on here, not to scare you, but more just to show you it's always the same pattern. Okay, you're going to have a congruent part. I start with red. So I have BA congruent to BC. So now I'm done with red, move to green. Same as all the other ones. BD bisects angle ABC. Here's BD, here's ABC. So what that means is that these two angles are congruent. Angle 3 is congruent to angle 4 by the definition of an angle bisector. Okay, green is done. Move on to blue. Well, I see that they have a shared side. So I'm going to use the reflexive property. I'm going to say BD is congruent to BD by the reflexive property of congruence. Now that I have three congruent parts, I can say the triangles are congruent. So I'm going to move on to black. So I'm going to say triangle ABD is congruent to triangle CBD. And from the markings, I have two sides and an angle, but the angle is included, so the reasoning is side, angle, side. So now what follows a triangle congruence statement is that Cpctc. But now, since there's a whole lot more steps after that, I need to decide what specific sides or angles I need to have congruent. Well, if I look at my next step, they want the measures of 1 and 2 to be the same. So I'm betting that they want angle 1 congruent to angle 2 so they can use that next reason. So now I'm going to be looking down this row. If I look at angle 1 and 2, this one would be written in here for you. I should have had that written in here. But this is the angle addition postulate. Okay. And then if I look at step 9, I see that what changed from 8 to 9 is instead of 2, they wrote 1. Well, that's because angle 1 and 2 are the same, so they replaced it, they substituted. So this is substitution. Now there's 2 measure of angle 1, so they added them together. So if they add on one side of the equation, of the equal sign, that's simplified. From 10 to 11, the 2 is no longer there. What they did is they divided. Division property of equality. And then for 12, if I look back to 5 and then use 11, if 1 and 2 are equal and 1 is equal to 90, what they did and is instead of measure of angle 1, they wrote measure of angle 2, that's substitution. So they're both 90 degrees, so they must be right angles. That's the definition of right angles. And then we have right angles to perpendicular. That's definition of perpendicular lines. Wasn't too bad. But just to show you that Cpctc does not always go last. Cpctc is almost towards the beginning of this one. But at least with the triangle proofs, you're doing the red, the green, the blue, black for triangles, Cpctc, and then whatever else they want. So that's when you use your, your proof skills from chapter 2.